All right, hello. Let's just wait for a few people. I think we have roughly grade 11s. Hello. We are going to be starting to look at exponential equations, my beloved grade 11. So if you know of a grade 11 friend that you think will benefit from a lesson like this, just call them over to come. All right, because the grade 11s, we've been looking at simplification of exponents now for the longest time. So now it's time to get into the equations, right? We need to get into the world of equations. Yeah, we need to get into the world of equations. Okay, so we'll start in the next few minutes. Whilst we do wait, let's double tap on the screen, guys. Let's get the likes up there. We've got 639, get to 1,000 likes, and let's get the show on the road. All right, let's get the show on the road, guys. Let's get the show on the road. I'm very happy that you all are here. Please, guys, do double tap on the screen. Double tap on the screen. It's always nice when people do double tap. Please do support the live creator if you possibly can. If you haven't followed, please follow, so that we can just be on this journey together as we go along. All right, so we're going to start off grade 11 exponential equations, but before we jump into that, we need to start off with the very basic understanding. Okay, what is an exponential equation? Okay, what is it? It is an equation. What type of equation is it? It is an equation in which the variable is in the exponent, right? So hopefully we all sort of like have an idea of what we mean by that. Exponential equation, it is an equation in which the variable is in the exponent. Okay, remember, guys, with an exponent, we have a base and then we have an exponent. So we call this a base and then we call this an exponent. So that's basically what we mean. So with an exponential equation, we're saying that it is an equation in which the variable, so the variable in and of itself is actually the exponent. So let's just look at a very useful property that we use when solving exponential equations. And here is the property. If a to the power x is equal to a to the power y, then we can say x is equal to y. So we repeat again. If a to the power x is equal to a to the power y, then we can say that x is equal to y. So if in a exponential equations the bases are the same, then we can simply drop these bases and simply equate the exponents. All right, So that's the beauty of exponential equation. So we can just say x is equal to y because we can clearly see that we have a this side, we have a that side. So then we just say the exponents are equal. And that's pretty much the basic rule that we use when solving exponential equations. So let's look at a few examples so that we can see the practicality out of this. Now, you guys are not learning exponential equations in grade 11 for the first time. Of course, in grade 8, you did it. In grade 9, you did it. In grade 10, you did it. So in grade 11, you guys should be pros, right? Goes without saying. So let's just say we had 2 to the power 3x minus 16 is equal to 0. And we are basically being asked to solve for x. So you guys will remember, what did we say? We said exponential equation is an equation in which the variable is the exponent. So here we go, guys. We have a variable that is a exponent. So this is t to the power 3x minus 16 is equal to 0. So how do I proceed? Chat, help me out in the comment section. 2 to the power 3x minus 16 is equal to 0. How do I start? Okay. So you guys can see that on the left hand side of this equal sign, there are 2 terms. How many terms? 2 terms. So 2 to the power 3x and minus 16. So there in the comment section, I see Anna says, take negative 16 over to the right hand side. Very sweet. Very good. Okay. Take negative 16 over to the right hand side. So can we do that? Definitely. 2 to the power 3x is equal to 16. Okay, right. Next, 2 to the power 3x is equal to 16. What do we do next? What's the next step? So we've transposed the negative 16 over, it became positive 16. Next step. Okay, get the bases to be the same. So 2 to the power 3x, this here is already a prime number base. Okay, so the 2 is already prime. It's a prime number base. It's raised to the power 3x. All we need to do now is we need to change this composite base to become a prime base raised to an exponent. So I like what you are doing there, Katleho. You are saying we need to change 16 to become 2 to the power 4. What if I have people here that do not know how to convert 16 to become a prime base? What they then can do, those people, they can basically say 16 is equal to, then they can press what? They can press the beloved shift, and then they can press the beloved fact. And then that allows you guys to convert a composite number base to become a prime base raised to a particular exponent. So that's how we do it. So then we have now the same base on either side. 2 to the power 3x is equal to 2 to the power 4. Now that the bases are the same, I can apply this property. If a to the power x is equal to a to the power y, what did we say? If the bases are the same on either side, we can drop the base and equate the exponents. So therefore we can say 3x is equal to 4. And then we proceed to solve, which means we divide both sides by our beloved what? Our beloved 3, right? Our beloved 3, right? And then x is actually equal to 4 over 3. All right, that didn't sound so bad. Okay, so what did we do initially in the question? We got the one term to the other side. All right, then we prime factorized. In other words, we wrote this composite number to a prime base. Then that ensured that we had equal bases on either side. Then we dropped the bases, we equated the exponents, and then we solved for x. We solved the linear equation that we know and love, that we used to solve in earlier grades, and that leads us to x is equal to 4 over 3. Okay, very nice, ne? Thank you, Romeo. Romeo seems to really agreeing with the rows. All right, that's very romantic of you, Romeo. Agreeing with the rose. It's like that is very romantic on a Sunday. Eh? All right, then let's look at another. 3 to the power 3x. You guys do this one for me. You guys can do this one for me, if you will. I'll give you guys 2 minutes. 3 to the power 3x minus 27. Let's see you guys work your magic. Right, 2 minutes. It's 3:36, 3:38. You can work it out. You have some time, and when you're done, you can just share 3 to the power 3x minus 27. We are required to solve for x. Oh wow, that was fast. You guys are fast. My goodness, you guys are fast. Sure. These people are so fast. It's like did it in my mind. Look at that. Like some people do it in their mind. All right, even though you guys do it in your mind, just remember for us to have the marks, we need to see steps. Hey, okay. So I get you. And I'm very happy that you guys do things in your mind. So I'm sure you guys got x is equal to 1. It seems like on the board, everybody is like x is equal to 1ing. All right, so yes, first step, we transpose, obviously, the constant. That is obviously what we can see because we only have one other term. All right, then thereafter, we use prime base factorization. We know if we don't know, we go to the calculator. 27 is equal to shift fact. Right, and we know what that is. That's 3 to the power 3, as you guys have done so beautifully. You then, bases are the same on either side, so what do? We drop the base, we equate the exponent. Final answer, divide both sides by 3, we get x is equal to beautiful 1. All right, so far we are doing so well. Thank you, Romeo, for the rows again. Yeah, guys, I think Romeo is the I guess Romeo, the name itself, now I'm thinking of Romeo and Juliet. You know, Romeo was a very yeah, man knows how to give roses, doesn't mess around, does he? Okay, let's look at another example. Example 3. Okay, 3 to the power 2x is equal to -9. Let's see how people deal with this one. 3 to the power 2x is equal to -9. We're doing grade 11 today. We're doing exponential equations. 3 to the power 2x is equal to -9, guys. Yes, because the grade 11s in their term 1, they look at exponents and surds. And those who have been joining my lives for the grade 11 lessons, we've already done and finished with exponential expressions and surd expressions. Now we are looking at equations. Those who are asking about grade 8 and all of the other grades, you are in the wrong page, guys. Wrong page. There's an alternative WhatsApp, there's an alternative TikTok page that is grade 8 and 9. So that's where when I do go live, grade 8 and 9 lessons. At the moment, no grade 8s or grade 9s have shown particular interest in these kinds of lessons because I haven't received any evident, you know. I also have WhatsApp groups. I don't have any members in grade 8, no members in grade 9. So to me, that just says no interest. So at the moment, I am not devoting my time doing grade 8 and 9 lessons. I know these people, they will be pressured later on in the year. They'll start wanting for real to have lessons. So for now, I know kids are kids. That's why I'm sure there's no real pressure. But if there are grade 8s and 9s, you can send me a private message and you can just let me know, sir, I'm interested, want to be part of the WhatsApp group and all of those things. All right. Unfortunately, Romeo, I don't do physics, but I do have a friend here on TikTok. His name is Mr. TK. You can get in contact. He's actually on TikTok, Mr. TK. He does both maths and science. Beautiful, amazing teacher, that one. Very good here on TikTok. The man, the ish. Ronique, grade 10, you can contact me on the side as well about grade 10 mathematics, that is. So we're busy with grade 11 at the moment, but yeah, if you want grade 10, all right, and maybe you want to be part of the WhatsApp group as well, please let me know. Just contact me on the side. Send me a private message, DM. So let's look at this, guys. 3 to the power 2x is equal to negative 9. Guys, let's be realistic. Let's go back a little bit. If we look at this x, that is 4 over 3, right? If you take this 4 over 3 and you do substitute it here in the place of x, all right, the substitution does lead to the answer, positive 16. Let me just show you. 2 to the power let's just say you have that 4, right? 2 to the power 3. Then you would multiply that with a 4 over 3. Question is, you see, when we substitute that x value there, we get the 16 back. Come back here. When you take the 1, you substitute it there. 3 times 1 is 3. 3 to the power 3 does give you 27. Now, I'm just looking at some of the answers that you guys have mentioned in the comment section, saying x is equal to negative 1. Some of you have said negative 1, and I also saw someone else say, no, x is 1. Okay, so let's look at these answers that you guys have gotten. 2 times 1 gives us 2. Then 3 to the power 2 is positive 9. I don't see a positive 9 on this side. Someone else is going to say, but sir, no, it's not x is equal to positive 1, it's x is equal to negative 1. Okay, let's look at it. 3 to the power 2 times negative 1, that gives me 3 to the power negative 2, right? But what is this? It's 1 over 3 to the power 2, which is 1 over 9. So once again, I do not see the outcome of negative 9. So x, a particular x value, is there a specific x value that I can substitute in the place of x, which when multiplied with 2 and the base 3 is raised to that exponent, which will give me an answer that is negative? Is that even possible? Okay, so please guys, these are times when you're looking at a problem, don't just rush, right? Yes. So I can see in the comment section now, people are waking up and they're like, there's no solution to this, there's no real solution. Very good. I love that you are thinking of that. Guys, take note. This rule of exponential equation says if a to the power x is equal to a to the power y, then you can say x is equal to y. The key thing here is that the sign of each variable base that we have there, a and a, they must both be the same sign. That's very important. So if they are positive, both of them, they must be positive, both of them. If they are negative, both of them, they must be negative, both of them. That's how you will have an actual solution in your equation. But the moment you have a base that is positive and the other one is negative, that should say to you, we cannot be able to produce such a outcome. Okay? So in other words, what I'm saying is that there is no way that 3 to the power 2x can be negative. So 3 to the power 2x cannot be negative. It's impossible. Do you see that, guys? All right, I hope you guys get the point. So we can just immediately say x has no solution. There is no need for us to move, all right, to move any further. You'll find some people saying 3 to the power 2x cannot be negative 9, all right? Yeah, so either or. X has no solution, all right? Yeah, that basically answers the question. X has no, because they wanted us to solve for x. Okay, so please, guys, let us be vigilant about these things when we are dealing with them in our problems. Okay, I hope we are together here. I hope we are together there. Okay, let's move on to another example. Example 4, right? I'm trying to just really build, I want us to build from bottom up, so that we are clear about concepts. That's why I'm starting at basic level. Okay, let's look at this. This is 25 to the power x plus 1 times 5 to the power x, and we are saying it's equal to 125. So the question is solve for x. 25 to the power x plus 1 times 5 to the power x is equal to 125. Unfortunately, L, I don't do grade 10 maths lit. Maths lit, guys, I don't do. Yes, too. I see you there in the comment section. We base 5 all the bases. Okay, base 5 all the bases. I think that's more appropriate. Base 5 all the bases. Okay, let's be very careful when we do that, right? So that we do not compromise the value of x at the end. So when we base 5 everything, let's make sure we base 5 appropriately and correctly, and do not deviate from the correct base 5 thing. Right. So 25, x equal to 1 over 3. I see, Anna, you've arrived at the I see you, Jay. Junior C, we this is grade 11, all right? This is grade 11, so we try and stay away from logarithms in grade 11 for caps, all right? The caps syllabus for grade 11, caps specifically, because my content deals with that specifically. Logs, we try and steer away from. Okay, let's just check with the answers. I see people are streaming in. So 25 can be written as 5 to the power 2. Right? All the people, the guys who are asking me about other grades, DM me about other grades. You can send me a DM and ask me about whatever you want to ask. But right now I'm busy with grade 11 exponents. So let us chill. 5 to the power x. 125 Exactly. 5 to the power 3. Okay, very good. All right, then thereafter, let's not forget what needs to be done. We distribute. Okay, hello, Sefamete, hello. 2 times x, 5 to the power 2x. 2 times 1 plus 2. Okay, yeah, we're busy with grade 11 at the moment. Sefamete, grade 12 later on, obviously at 9 p.m. as usual. Grade 12, 9 p.m. as usual. Busy with grade 11 now. Times 5 to the power x is equal to 5 to the power 3. Okay, so let's be careful there. When we change a base where there's an exponential expression, we make sure we put it in brackets. Our change must be in brackets so that we distribute the exponent. And we distribute the exponent, guys, 2 times x, 2 times 1. Please don't distribute just to the x, we distribute to the other term as well. Okay, now we can see on the left, all right, we can apply law number 1 of exponents. 2x plus 2 plus x. We do that, guys. 2x plus 2 plus x is equal to 5 to the power 3. Now that there is one single base and one single base on the left and right, our rule can be applied. We can drop the base now and equate the exponents. 2x plus x, that's 3x. We take the 3 minus 2 to the other side. Of course, we get 3x is equal to 1. And then we divide both sides by the coefficient of x. We get x is equal to 1 over 3. So you guys were 100% correct in your conclusions that x is equal to 1 over 3. Very good. Guys are phenomenal. Beautiful stuff. We've got pros here in the live. No doubt. Let's look at another example. Example 4. 4 times 8 to the power 2x minus 1 is equal to 0.125 to the power x minus 1. Okay. Now, my people should know what we need to do first before we proceed any further. Oh, sorry, example 5. My bad. Thank you. Yeah, not example 4. Okay, very good. I love the fact that you guys are even observing those minor errors that I'm making. Great stuff. You guys are just going to, hey, we've got academic slayers here. Academic slayers for she's in Menizal. 4 times 8 to the power 2x minus 1 is equal to 0.125 to the power x minus 1. Give you a chance to do it, of course, before I jump in. Okay, this is supposed to serve as sort of like a revision for grade 10. Remember grade 10, we did these problems, so it's not like new stuff. Yeah, now we want to solidify that understanding so that as we do grade 11 exponential equations, we've got a solid base that we're working from. All right, so yes, grade 11s in the Hizzles, exponential equations for my grade 11s. Booyah. But even the grade 12s most, they need to be fine with such. They shouldn't be having difficulties, grade 12s. Okay, what would we do first in a question like this? Okay, because we've got a base 4, got a base 8. These are both composite bases, you know. 0.125, we've got a decimal even. Decimal is not even a prime base. So 4, 8, we got 0.125. So it seems like there's quite a few things that we need to make sure that we are able to take care of. And by the way, this decimal number is what we call a terminating decimal. Terminating decimal, a type of rational number. A type of rational number that can be, obviously, as a decimal that is terminating. You can express that decimal as a fraction, right? All terminating decimals can be expressed as a fraction. So that is our goal and objective as well, so that we can then go ahead and do the things. Okay. Smash 1, 2, 3. Wow. Smash 1, 2, 3. Yeah, feast our grade 12. Yes, grade 12 I take care of. I deal with grade 12 in the evening at 9 p.m. And yes, I do grade 12. Grade 10, if you want grade 10, you must DM me. I have a, yeah. Okay, our 4/9 final answer. No, 4/9. People are getting 4/9. It seems like we are 4/9ing. 4/9ing. It seems like there's a rain of 4/9 that is falling upon our heads. Right? So let us tread very gently. 4 times 8 to the power 2x minus 1 is equal to. Now we need to convert this 0.125 to a fraction because it currently is a decimal. Guys, what's nice is that your calculator can serve you in those purposes. You know, you might not know what 0.125 is. You go there to your calculator, say 0.125 and press equal. Do you see what your calculator does? It just gives you. It gives it to you. This calculator, it just gives it to you. Now you have 1/8 to the power x minus 1. Now all you want to do now is change these bases to prime. 2 to the power 2 kind of sounds good. 8, 2 to the power 3. Then remember, we write the expression on the outside. Okay. Equal 1/8. Guys, remember that 1/8 can be written as 1/2 to the power 3. Right, because 8 is 2 to the power 3. But you can then express this as 2 to the power -3. You see, guys? So now we are applying our exponential skills. So I'm not even going to write 1/2 to the power 3. I'm going to go straight to 2 to the power -3 because I know 1/8 is 1/2 to the power 3, which is equal to 2 to the power -3. You see, prime base factorize. How beautiful, guys. Okay, applying the negative exponent, understanding that we know. All right. Yeah, it's lit. It's lit, guys. X minus 1. Exponential expression on the outside. It's lit, guys. It's lit. Super lit. Super duper. Then now, what is nice there is that 2 to the power 2 can kind of take a break. Let's distribute what we have. 3 times 2x, 3 times -1. Algebra skills being put to work. Distribute. Distribute. Let's distribute the -3 there. 2 to the power -3x plus 3. Right, you guys are doing phenomenal there in the comment section. I see your answers. I'm very proud. Now, on the left, the base 2 is being multiplied. So let's add 2 plus 6x minus 3. Base 2 -3x plus 3. Now, bases are the same. So what we can do is we can drop the base 2 and we can equate the exponents. Then guys, from here we are back in grade 8. 6x, take -3x as a term to the left hand side, it becomes plus 3x. Plus 3 is fine on the right. Take -3 over, becomes positive 3 because the sign changes. Positive 2 gets transposed to the right, it becomes -2. And then we get 6x plus 3x. Remember, when we are adding like terms, we keep the variable, we add the coefficients. What's 6 plus 3? It is 9. 9x. Then we say 3 plus 3 is 6. 6 minus 2 is 4. Snoko. Vulama boto, right? And then we divide both sides by the coefficient of x, which is 9. divide both sides, we get x is equal. Look at that beautiful answers that you guys got. W's in the maths game chat. You guys, next level. Like some of you are like the iShow speeds of maths is a game, because you do this with such accuracy and with such speed, and you report in the comment section so quickly. Hi, next level people here that we have. Man, maths is got to have maths is going to have another problem with us this year. We are going to take it down. We are going to seriously be taking down maths like nobody's business. In for a ride with us. All right. Yeah, guys, these are once-off examples. Getting similar ones is something that you have a responsibility to do. So I know some of you have bought your stationery. So go ahead and you've bought your textbooks. Open it up. Open up those textbooks. Check what is there. Check the problems that are there. Go look for the problems. Go look for them. Yo, ngazo. Yeah, your question. Why are you kidding me? Wow. 5 times 3 to the power 2x plus 6 minus 5 is equal to 0. Let us solve this one too. So let me give you guys a chance as usual. Solve it up. 2 minutes. No problem, see you later. Let's solve it up, my grade 11s. 5 times 3 to the power 2x plus 6 minus 5 equal to 0. Let us solve it for x. My beautiful people. Look at this one. Jaden is like, the answer is 67. Is it? That was very quick of you. Thank you guys for the support. Really appreciate it. Thanks, Ngutuka. Thank you, Romeo. Romeo, Wangolota. Remember that song, Romeo? 5 times 3 to the power 2x plus 6 minus 5 is equal to 0. Let's solve for the x. Let's take it down. Let's do it up. Okay, I see various answers in the comment section. Let's be very careful when we do our calculations, guys, to ensure that we do not deviate and find ourselves in thick water. Solve for x without using log. Solve for x. Solve the following equation. Okay, I see many responses in the comment section. Some of them, they are very pretty. Some of them are very helpful. Okay, this is 5 times 3 to the power 2x plus 6 minus 5, which is equal to 0. All right, let us proceed. All right, let us proceed. So this one, we can see we have 2 terms on the left hand side. We have 5 times 3 to the power 2x plus 6. The 5 there that we can see. All right, I'm guessing depending on who's doing the problem, you may find that people may approach this problem differently. Depends who is doing the problem. Okay, but I'm sure you guys can see that This is a base 5, there's a base 3, different bases. Okay, so for now, let us isolate the 5 on the right, which we can do. The negative 5 goes over, it becomes positive 5. This 5 here that is multiplied, let us divide by 5 this side so that we can get rid of it. But remember guys, whatever you do on the left, you must do where? Can we divide by this 5? Yes. Why? Because this 5 is multiplied to 3 to the power 2x plus 6, the whole entire thing. So it's okay to divide by the coefficient of this entire thing. So we divide by 5, but remember what you do on the left for one term, you must do on the right. Okay, what does that lead you to? It leads you to 3 to the power 2x plus 6, which is equal to what? 1. But I'm sure you guys know that the 1, if this is base 3, then we can write 1, yes, as 3 to the power what? 0. This 1 can be written as 3 to the power 0. Why did we specifically choose to write it as 3 to the power 0? It's because the base here on the left is base 3. That's why we pattern the base that we choose according to the base that is on the left hand side. Because here 1 can be written as any number to the power 0, except of course the base 6. It can be written as any number to the power 0, so we choose base 3 specifically because we already have a base 3 on the left. We clear, ne? I hope we are very clear with that. Then bases are the same. Drop the base, equate the exponents. Hi, from there guys, we're back in grade 8. Transpose the 6 to the other side, it becomes negative 6. Then we divide both sides by the coefficient, we get x is equal to a negative divided by positive. So to all those that wrote positive 3, no guys, it's not positive 3, it is x is equal to negative 3. All right. And in all situations, you can always verify your answers, with quickly just, seriously, if you take your calculator, I'm just thinking if I took and substituted the negative 3 there, that's 5, and look at this, 5 times, that's 2, 5 times 3, 5 times 3, okay, to the power, so the exponent 2 multiplied, we're multiplying by negative 3, remember? Yeah. Then we go down there, next 2, that's minus 5. If we get the 0, then of course, wait, that's 5 times 3 to the power, let me just, do that again, that's 2 times this, the 3, 2 times the negative 3, we put that in brackets, so we've got the plus 6 there, minus 5. What am I doing wrong here? Negative 3. What am I doing wrong here? 5 times. Oh, I think it's a dot. Sorry. Should be saying multiply. What am I doing? 5 times, guys, not dot. There we have it. You see, me, I literally put the dot there instead of putting multiply because remember the dot means multiply. Yeah, the dot means multiply. Okay, so yeah, you can see the outcome does come out whenever we substitute that x is equal to negative 3, so it's correct. All right, so far so good. Exponential equations, example 7. No, we're just pushing it out with examples here. Let's see. Square root of 4 to the power x. is equal to 1 over, sorry, 4 to the power x is equal to 1 over square root of 4 to the power x is equal to 1 over 8 to the power x plus 1. Okay, let's look at this one, guys. Okay, give you a moment, give you a sec, do it, and then in the comment section let me know what you guys get. Why 4 square root of 4 to the power x is equal to 1 over 8 to the power x. What do you all get? Sure, guys are fast. Got Mr. Impact there with negative 3 over 4. We've got Enro Delvise having a negative 3 over 2. I wonder if those answers are actually correct, or is 1, because negative 3 over 4 is different from negative 3 over 2. Those are different answers altogether. Oh man, we've got x is equal to 1, we've got x is equal to negative 3 over 5. Various responses are coming out. Various responses are coming out, which is indicative of the fact that we are breathing differently. We are breathing different air. Negative 3 over 5, negative 3 over 4, negative 3 over 2. These are tricky without paper. Oh man. Yeah, it's key though to like have because yeah, unless we get the practice happening, guys, yeah, what other possible way do we expect to be able to do things, you see? So it's key, it's very important. Yeah, but there's various answers that people are giving here in the comment section. But I see what the misconceptions are. All right, and I see what the misconceptions are. So let's look at 3 possible attempts. Maybe someone else was looking at this is like, why don't we just write 4 as removing the exponent, the square root, as 4 to the power x over 2, right? That's someone else who's looking at this. And then they go ahead and they say, then let's write this as 8 to the power negative x minus 1. Do you see what happened here? This side on the left, we applied this rule for rational exponents. When we have a to the power m, the nth root, we can write it as a to the power m over n. So that there is being applied to 4 to the power x, to write it as 4 to the power x over 2. Then if you look at 1 over 8 to the power x plus 1, this can be written because we know about for instance, if we have a1 over a, this can be written as a to the power negative 1. So what we do is we change the base, we change the position of the base from the denominator to the numerator. When that happens, when you change the position of the denominator to the numerator, the exponent changes from positive, because obviously this was 1 over a to the power 1, to negative. So this is the same thing we are doing. In the denominator, we have 8 to the power x plus 1. So what we are doing now is that when we rewrite this so that 8 is the base, we change the position of 8, moves from the denominator to the numerator. What happens to the exponents? The exponents they change sign. So the power positive x becomes negative x. The positive 1 becomes negative 1. So this is how now we achieve same bases on either side of the equal sign. Then we can change 2 to the power, we can change the 4 to become 2 to the power 2 raised to the power x over 2. The 8 becomes 2 to the power 3 raised to the power negative x minus 1. I think bases are nearly the same. We multiply the exponents. 2 times x over 2. That 2 and that 2 can cancel each other because 2 divided by 2 is 1. We are left with 2 to the power x on the left. Okay. Then on the right, you distribute the 3 to the 2 terms. 3 times negative x, 3 times negative 1. So 3 times negative x, that's 2 to the power negative 3x. And then 3 times negative 1, that's negative 3. Bases are the same. So when they are the same, you drop the base, you equate the exponents. And then after that, what do you do? Alright guys, linear equation. We are back in which grade now? Grade 8. Should be easy as a cinch. Should be easy as a cinch. Should be easy as a cinch. So x plus 3x is equal to negative 3. On the left, when you add those like terms, you get 4x. On the right, you isolate the negative 3. You divide both sides by the coefficient of x. So you can see, guys, that the answer is supposed to be negative 3 over 4. Now, if you did get a different answer, you need to check what is it that you may have possibly done that was leading you to the incorrect answer. Make sense? Now, I said there are many ways you could do this problem. Some people who are doing this problem could look at it in this way. You can cross multiply. This is 1 over, this is 8 to the power x plus 1 in the denominator. You could cross multiply, isolate 1 on the right. You change all the bases to base 2, and then you do your distribution, you should still get to the very same answer, -3/4. Or you could have just initially from the beginning changed the 4 to become 2 to the power 2 raised to the power x. Then you apply the root form, you simplify, you do the left and the right, you get the answer. Okay, right? So there's many ways to do this and you will still arrive at the same answer. Okay, does that make sense? Yeah, but remember guys, this is still at the beginning. We are still starting exponential equations from the ground up. So yes, many other questions are there, but we are still doing the fundamental basics for exponential equations so that yeah, we have, you know, a little bit more to see. All right, yeah guys, you must also attempt and see. This guy can't be doing everything. All right, and everything I've been doing so far is very basic. Okay, right, let's give people a chance. Let's see if you guys, what prevails when you do this. Okay, so that's, sorry guys, just so you see, this is 9 to the power x minus 1, which is equal to 27 to the power x, I'm sorry about the, times 3 to the power x plus 2. Right. All right, so yeah. Okay, I'm getting a lot of x is equal to -2. Like in the majority, it seems like people are just busting out x is equal to -2 in the majority. Question is, what's happening with everybody else? Is this really like... Okay, nice. I love it. I love the fact that, yeah, you guys are correct. It is x is equal to -2. I'm not even going to do it because it is x is equal to -2. If you got something else, then it means you're... All right. All these 9, 27, and 3 need to be based 3. All right. Okay, let's just do it because I feel like if I don't, I'm going to be slayed. 9, 3 to the power 2 in brackets, you see, leave x minus 1. 27, 3 to the power 3 in brackets, leave it. 3 to the power x plus 2, obviously that's already a prime base. Then we distribute the exponent. 3 to the power 2x minus 2 is equal to 3 to the power 3x times 3 to the power x plus 2. All right, so grade 11, I hope we can see this. And now we have base 3 on the left, 2x minus 2. We apply law number 1. When the bases are the same, what do? We keep the base, we add the exponents. Please, guys, now we have individual single bases on either side. So what do? We drop the base and we solve. What do you guys get? 2x minus 3x is negative x. Negative x minus x, negative 2x is equal to 4. Divide both sides by negative 2. Getting ahead of ourselves here. Then x is equal to negative 2. Okay, easy as a cinch, right? Easy as a cinch. Easy capeasy, manizi. Easy capeasy, manizzle. Shizzles, shizzle, manizzle. Okay. Yeah, now I see. I was blind, but now I see. Now I want to enter into another sweet problem. Okay, here we are, guys. 4 times 9 to the power x minus 27 is equal to 3 to the power 2x plus 1 there in the exponent. Solve for x. How do we solve for it? Let me first allow you guys to do this. Let's just see, because I'll see the true grade 10 learners that, you know, knew their stuff, because this is just grade 10 revision, if you will, and these are problems that most majority should know how to attend to. So let's see. Do it step by step, right? Give you some nice 3 minutes to 3 minute the problem. All right, you guys are wanting to give me a big head. I have a very big head, guys. If only you could see it. It's so huge. Yeah, so huge. So you guys saying all of these nice things there, that it's so fun here. I don't know how happy you're making me, but I guess the numbers speak, right? I see people in the stream here. At least have 170 odd people that are here. Hopefully majority are grade 11 for real. I can sense that there are adults here as well. I can also feel that there are grandmas and grandpapas. I can also sense that there are little babies there that are here as well. They are watching, like they want to get the maths whilst they're still in diapers. It's amazing, man. It's amazing. Yeah. 4 times 9 to the power x minus 27 is equal to 3 to the power 2x plus 1. P-way. Love curious people. Yeah. All right, we are in 13.7k likes, guys. It's been really good. Thank you so much for the likes there. Very lovely 13.7k likes. And also thank you for the occasional surprise. It's always nice to be surprised. I hope you know what I mean when I say the occasional surprise. Thank you so much for that. Waswa Frederick Lutaya, x is equal to 3/2. No messing around. impact is also impacting with one pact with x is equal to 3 over 2. Nelisiwe is like high school. Where are you, Nelisiwe? Are you in varsity? Nelisiwe is in grade 12. Okay. This is grade 11 exponential equations, but of course for grade 12s, where grade 12s will never hear the language of exponential equations. Grade 12s in South Africa will never hear. Grade 12s in South Africa will never hear the language of being taught exponential equations in their grade 12 year, unless it is revision before an exam, or it is just to recap something that's important. So this is also nice for grade 12 learner to just remind themselves, not so much that it's something that they will learn in grade 12. One impact. Do you stream every day? Yeah, I am the new iShow Speed of Maths, my friend. I'm streaming every day. iShow Speed of Maths. That's me. You might as well just call me iShow Speed of Maths. Unfortunately, the TikTok page is Maths as a Game, but I am the iShow Speed of Mathematics. To stream every day. Imagine. Okay, we're getting similar answers. 3 over 2, 3 over 2, 3 over 2. I'm guessing these are legit responses that are coming through. Alright, and I want you guys to observe a pattern between the approach of this question compared to all the other questions we've been doing. Okay, because this one is very interesting. This particular question, this particular one. All right. This one has x. Yeah, and all the others also had x, my guy. They also had x. There's the exponent. No, that's not what makes it different. All the others also had x as in the exponent. No multiplication. This one has multiplication. Is that what you are saying? This one has multiplication. The others had multiplication as well. 27 to the power x times 3 to the power x plus 2. Oh, no multiplication. Oh, I see. One impact. Thank you so much. Love your energy. Thanks for your energy as well. Really appreciate you as well being here. You have been a great energizer to the energized, and they're continuing to be energized. Thank you, my brother. Thank you, my brother. Or is it thank you, my sister? Which one is it? Guys, don't be scared to support me there with the live goal. I've got live goals there. You can check there in the corner of my right. Don't be scared to support me there in the live goal. Some of you need to break new ground. You've never gifted anyone in your whole entire lives, so don't be afraid to go and go to that mystery gift box there at the bottom corner of your Lantuga, and you can choose there and you can just give. All right, anyways, some of you are very good givers at church. You give money. You can also give to the live stream. It's Sunday. 4 times 9 to the power x minus 27 is equal to 3 to the power 2x plus 1. So I love the fact that most of us, we said the answer, and it should be, it is indeed 3 over 2. All right. Now 4. Go to hold my horses there with the 4. All right. The 9 can be written as 3 to the power 2. All right. 27, I'm going to kick 27 out of here. I want to bring 3 to the power 2x over, and I have reasons for doing that. 27, I'm going to chuck him out of here to the other side. I said. Teacher, remember I said. Yes, you did. All right. So for this exponential equation, we can clearly see that unlike the previous ones, here we had on the left one term, on the right one term. Guys, terms are separated by a plus and a minus sign. I repeat, terms are separated by a plus and a minus sign between the bases. So for instance, 27 and 3 to the power, this is not separated, it's combined. There's a multiplication sign. All right, turn over the page. This square root 4 to the power x is equal to 1 over 8 to the power x plus 1. We have 1 isolated on the left, 1 isolated on the right. This 5 times 3 to the power 2x plus 6 minus 5 is equal to 0. Okay, we have two terms currently on the left hand side. The minute we transpose the 1, we have 1, 1 again. This problem here that we did, that example 5, how many terms on the left? 1. 4 times 8 to the power 2x minus 1. 1 term on the left, 1 term on the right. This example 4, 1 term on the left, 1 term on the right. This 3 to the power 2x is equal to negative 9. 1 term on the left, 1 term on the right. This 3 to the power 3x minus 27 is equal to 0. The minute I transpose the 27, 1 term on the left, 1 term on the right. This 2 to the power 3x minus 16 is equal to 0. The minute I transpose, 1 term on the left, 1 term on the right. This one, slightly different, because 4 times 9 to the power x minus 27, I have 2 terms on the left, and then there is 1 on the right. So that then says to me, if I'm going to be solving this exponential equation, my approach is going to be different because my terms are actually separated by a plus and a minus sign. So there is some sort of factorization skill that I'm going to have to apply, whether that be highest common factor, 2, difference of 2 squares, 3, trinomial quadratic type factorization. All right. So I have to then be vigilant and take these into consideration because it is possible. All right. So we are going to see here which one is going to be taken into effect. Now, the minute I change my base, which has a variable, to its exponential prime form, I am saying that this is 3 to the power 2. Already on the left hand side, I have base 3 raised to the power 2. You see? So what I do is I'm going to quickly rearrange my terms. I take 4 times 3 to the power 2, that's fine. Let's just multiply that 2 times x, that gives me 3 to the power 2x. And I'm going to quickly bring his brother from Zimbabwe, because he's currently in Zimbabwe. And the same family member is in Zimbabwe, but we are waiting for him in South Africa. So I'm going to take the brother from Zimbabwe because 2x in the exponent, 2x in the exponent says we are family. I'm taking him over. Then this negative 27, I'm taking him over. All right. So why am I doing that? Because if you guys remember from when you did grade 10, you often had questions like this, where you had 2 terms on your left where you could clearly see that there is a possible common factor base with a common variable exponent. So that would scream very loud that there's a highest common factor you have to take out. But in order to discover it, you need to first split the bases. So we are going to do that. We're going to play Mr. Splitting of the bases because we have the same family members in the exponent. So 4 times 3 to the power 2x is already split. We split this second term. When we split it, guys, it becomes 3 to the power 2x times 3 to the power 1. I am using the reverse of law number 1. You know, most law number 1 says when you are multiplying same bases, you keep the base, you add the exponents. Now I'm dissolving what has been combined by law number 1 of exponents. I'm dissolving it into its separate bases. Does that make sense, guys? And I am seeing on the left, there's someone who is common. My family members, all right, that are from Zimbabwean heritage. 3 to the power 2x is common for these two terms. So what am I going to do? I'm going to take out that base with the variable exponent that is common. Take it out. All right, makes sense, guys? So far, I hope we are going together. Hopefully you are moving with me. That's why I did the rearrangement. I could see 9 being strategically placed, that when I change 9, which is the composite base, to a prime base, 3 to the power 2, it then leads me to 3 to the power 2x. But the family member is on the other side, so we need to take him and transpose him. When we do, it becomes negative 3 to the power 2x. The constant I needs to go. Why do we take the constant over? It's because we can see there is commonality of coefficient with the variable 2x, 2x. So highest common factor. That speaks to me very loud that there's a highest common factor that I'm going to be taking out on the left hand side for the two terms. So when I take it out, what gets left behind? On the left, when I take out 3 to the power 2x, what gets left behind on the left for my first term in the bracket? Who gets left behind when I take out 3 to the power 2x for my first term on the left? When I take out 3 to the power 2, who gets left behind? 4. Then on the right here, I took out 3 to the power 2x. Who gets left behind? It's the negative 3, which is equal to 27. You see? Hey, I hope we are together here, guys, and we are feeling this moment that we are in. So that is why I was speaking about the fact that when we have more than 2 terms and we are separating them by a plus and a minus sign, that says to you there is a particular type of factorization that you are going to have to apply. And in this situation, by rearranging the terms and seeing the base with the variable exponent having the same coefficient, then that means a common factor is going to be taken out. So after splitting, I take out that common base with a variable exponent, which is 3 to the power 2x, and I get 4 minus 3. What's 4 minus 3? It's 1. So I have 3 to the power 2x times 1, which is equal to 27. Now, guys, we know that 3 to the power 2x times 1 just gives me 3 to the power 2x. On the other side, I have 3 to the power, change that base, guys, that base 27 to its prime base, which is 3 to the power 3. Okay. Of course, if this was a number, I would treat it as the coefficient of 3 to the power 2x and divide both sides by whatever that number is. But it's just fortunate that I have 4 minus 3, which is 1. Makes life very easy because you multiply this, you get 3 to the power 2x, you change the 27 to prime base, so it's 2x is equal to 3 because bases are the same. You drop the base. We are back in grade 8. Back to grade 8. In fact, at this stage, we are back to grade 8. From here onwards, grade 8 stuff. And I don't know how grade 11s or grade 12s can be defeated by grade 8 work in grade 12. I don't know how that happens. Yeah, because from this stage onwards, we are flying freely with grade 8 work. All right. Thank you so much, Pure, for the roses. You are very much appreciated for the extension of the gifts. Yet a child, but appreciating. Thank you. Thank you so much. Thank you. W is in the chat for Pure. Right. So please, guys, when did this idea of splitting has its foundation from the fact that the minute that we see that for two terms that are separated either by a plus and a minus sign, we can see for the variable exponent, the coefficients are exactly the same. Then it means there's a common factor that needs to be taken out. Right? That is the approach for when we have a plus and a minus sign between, guys, the terms. So be mindful of that. All the problems we did before did not have that situation. All the problems we did before just had multiply, 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 multiply and divide, multiply and divide, multiply and divide. Whoosh. All of a sudden we have a plus and a minus in between, and it's like, wake up. Do not fall into the trap. Now we have to wake up to factorization. There is a type of factorization that has to be applied in this situation. So therefore we need to be aware of the terms that are in our equation. So we call these common factor type. All right. So here's the note that you need to take into consideration. When what? When take note of what I'm about to write down, because it's very important. When all bases, when exponential equations involve addition or subtraction of several terms. As I explained, terms are separated by a plus and a minus sign. Then you will notice that there's a type of factorization that is required, that is needed, that needs to be applied. All right? So you must look at the exponents, but only after you have dealt with the exponents. You see, for instance, this 9, I would never have seen the 2x that I see here unless I would have actually prime factorized that 9. You see? Does that make sense, guys? Then after doing so, I could see, for the same base 3, for different terms, for the same base 3, for different terms, Chini, we have family members that are the same. The exponents are the same. So when the coefficients, guys, remember, this is a variable, this is a coefficient, the number before the variable. So when the coefficients of those variables are the same, all right, then it means highest common factor type can be applied, all right? But this is only when exponential equations involve addition or subtraction of several terms. Then that type of factorization, highest common factor, may be required. All right. Hey, I hope you are hearing me well, guys. All right. Okay. Here's another one. Just for you guys, gang. This is yours. Here's some food. Eat 3 times 9 to the power x minus 3 to the power 2x minus 1 equal to 24. Let me give you a chance, guys. You can do this one as well. Okay. You can do this one as well. Yeah, this is grade 11. For those who are asking, grade 11 exponential equations. This is, I don't know even if it's like our 7th or 8th session since December dealing with exponents and surds for grade 11. We've done simplification of exponents, both exponents, and we've looked at simplification of surds. All right. Yeah. Now we are dealing with equations. And just a heads up, for those who would like to be part of my famous, I'm just kidding, man, it's not a famous, but those who would like to become a part of my proactive maths group for grade 11, so that you can get continued support for the year. Also, just so that I can always check on progress, if you need help, and it does not necessarily that you need me to go live, but you just need help on something. You guys can actually just DM me. You can DM me, send me a message with your interest on being part of the group. Unfortunately, guys, there is a fee attached to it. It's not free, unfortunately. I'm sorry. I know you guys love freebies. Like, for instance, you are loving being here, watching, and just being taught, without having to really of course, it's the TikTok data and stuff, but I mean, you know what I mean. So for that additional support, then obviously there's a fee attached. There's a monthly fee, but to find out about it, you have to DM me. I can't just talk about it here. DM me if you want to be part of that, just so that you have continued support for the entire year. That's up to you. You don't have to be. I can see some of you are very good. You are amazing, you are beautiful, your maths is beautiful, it's amazing. I can see even your answers are beautiful, you are beautiful, everything is just beautiful about you. So if you are beautiful, stay beautiful and be beautiful, and your maths must be beautiful continually. So 3 times 9 to the power x minus 3 to the power 2x minus 1. I see people answering in the comment section. Awele has aweled, Ngiana has ngianad. Let's see what everybody else has to say. Remember, guys, that sometimes even the answers that are written in the comment section do not necessarily mean that those answers are correct. And just because everybody is writing the same thing, you'll be shocked sometimes that Charlie, that answer, it is actually in actual fact nonsense. Or you find that that answer is heaven itself on earth. So it depends. Situations warrant us to consider these things. Okay. All right. Yeah, and tomorrow, guys, grade 12 results are coming out. Woo! Yo, guys, tomorrow, tomorrow is the day. Tomorrow is the day. I'm so excited. I just can't hide it. I'm gonna lose control, and I just can, man. Your stress. No, Afiga, no stress, my guy. No stress. Exciting times up ahead. Bum ba bum bum ba bum 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 bum. Okay, guys, 2 people have given me, but it's fine. Take your time. Work through it, guys. Work through it genuinely. Work through it genuinely. Because unfortunately, when you are in the exam venue, there's no one to actually, yeah, Bati. Remember, Bati, from the previous question, did we factorize 27? No, but like I said, sometimes the 4 minus 3 may lead to a specific value. Whatever you get here in the bracket may lead to a specific value, and then that value, you will treat it as a coefficient. You divide by whatever you get from the bracket. You divide by that both left and right. That will simplify things, and then you'll isolate the base with the variable exponent and solve. So the example or the problem above did not showcase us having a value that is not 1. But I'm sure for this one that you are doing, you are going to see that in the bracket, you have a value that's not 1. So you just use that, you treat that as the coefficient. You treat this entire thing as a variable. You divide both sides by it, or you multiply by its reciprocal, left and right. You should be able to simplify it and get to the answer. Okay, so please, guys, let's we're getting locked in, right? We're getting locked in, and yeah, pre-stuff, pre-before. All right, okay, let's work through it then. So this time round, we have 3 times 9 to the power x minus 3 to the power 2x minus 1 is equal to 24. So unlike the previous problem, remember in the previous problem, they made it a bit harder for us. We had to take this and transpose it to the right, because we saw that base 3 variable exponent, the same as that. That's where we can actually then, after transposing that and taking that to the other side, we could take out the common factor. This time round, it's heaven, right? It's heaven, right? Because they've isolated the constant for us, so we don't have to stress. All we need to do now is just see. We have 2 terms on the left. So once again, when exponential equations involve addition or subtraction of several terms, what do? We know that some sort of factorization is going to be required. So here, this is the situation. We change that 9 to be 3 to the power 2x. Okay. 3 to the power 2x. 3 to the power 2x. Minus 3 to the power 2x. Of course, what do we do with this? We split it, right? To become 3 to the power 2x times 3 to the power negative 1, which is equal to 24. Make sense, guys? Kind of did one step, in one situation. Change 9, 3 to the power 2x. Split 3 to the power 2x minus 1 to respectively 3 to the power 2x times 3 to the power negative 1. Okay, does that make sense, guys? Hope it makes beautiful sense. Now, after seeing the same, my Zimbabwean family, sorry guys for using that example, but I mean, you get the point. Family, same base, family. We can't add the exponents for separate terms, guys. We can't do that. Let's not fall into the trap of doing that. Okay, let's not fall into the trap of adding. Yeah, if you want to use K method, you can go ahead, but in this case, as I said, we can clearly see that we can take out the common factor, specifically the base with the variable exponent, the same base, same coefficient for the variable, 2. So we take out 3 to the power 2x as a common factor, just like we did here. Okay, then what do we get left with on the left? 3. What do we get left with on the right? minus 3 to the power negative 1, which is equal to what? 24. Okay, makes sense? I hope we are together there. 3 to the power 2x into 3 minus the 3 to the power negative 1, it becomes 1 over 3. Then guys, it's easy, this thing. You don't even have to use your addition. Just take your calculator. 3 minus 1 over 3 if you don't know it off by heart. Okay, 3 minus 1 over 3, that gives us what in brackets? 8 over 3. Okay, so we can treat this as the variable. 3 to the power 2x can be treated as a whole, as a variable. This is the coefficient. So what we are going to do both sides is we are going to divide by 8 over 3, which is the same thing as multiplying by 3 over 8. Okay, KCF, keep, change, flip. Remember, if we divide by 8 over 3, it's the same thing as multiplying by, we keep, we change, divide, we flip 8 over 3 to become 3 over 8. So what we do on the left, we do on the right. We are multiplying by the reciprocal of 8 over 3, which is 3 over 8. You could do that too. Dividing by 8 over 3 is the same thing as multiplying by 3 over 8. Okay, remember guys, that and that cancels, and that cancels. We are left with 3 to the power 2x on the left. What about this side? You can just grab your calculator and multiply this if you don't know it off by heart. But if you do, then of course you know that the answer will be 9. Okay, 24 times 3 over 8. 8 goes into 24 3 times. Then 3 times 3 is 9. Make sense, guys? Then this is 3 to the power 2x, whereas 9 can be written as 3 to the power 2. Now what do you see? Bases are the same on either side of the equal sign. We are back at grade 8 solving an exponential equation, which we know when we have the same base on either side, what do? We drop the base, we equate the exponent, we divide both sides by what? By 2. We get x is equal to 1. All right. Okay, any questions? Any major questions, my people? Any major questions, my people? Molimo, you got yourself a new follower. Do you know how happy I am to have you as a follower, Molimo? You have no idea. Like all the people that are my followers, like legit, genuinely, like you have no idea. You know, like there's just a different feeling that I have every time I have to go to my homepage and then I see Haibo. I'm like, Haibo, so many people. It's mind-blowing. Like it's just, I would have never thought this. Once upon a time, I remember when I started off this page, this TikTok page, I started it off, and I think I posted one of my first few videos where I was explaining like some grade 8 stuff and grade 9 stuff, and like the views were so low. I was like, I don't know, this math is a game thing, if it's ever going to kick off. Then I started doing live lessons for grade 8 and 9, and it was just like insane. So many people were joining, and then like with time it's just grown and grown. Okay, so it's been insane. How did you get 8 over 3? 3 minus 1 over 3, my guy. When you subtract 3 minus 1 over 3, you can just use your calculator to subtract that. Okay, you will get 8 over 3, my guy. Thank you so much, Anna. Anna is very active in the comment section with just trying to help you guys. Thank you so much for manifesting that, my dear. 100k peeps, that would be just like on another level. That would be so insane, fairy tale. Okay. So yes, 3 minus 1 over 3, that's what gives us 8 over 3, my dear. 8 over 3. Hopefully you understand now. Then we multiply by the reciprocal of 8 over 3, which is 3 over 8. We do that on the left and the right so that we can simplify. Back to grade 8. What's the whole purpose of doing this? Back to grade 8, guys. Back to grade 8, when life was fun and carefree. When life was fun and carefree, and solving for x was so sweet, eh? Yeah, those were the days, weren't they? Hopefully it was. Those were the days. Right? Yeah. So I'm actually just going to write one more problem so that you guys can do that one. I'm not going to step into doing solve for x problems that have to do with the other types of factorization. I'm going to save that for the next live lesson tomorrow. All right. So for now, I'm focusing primarily on when exponential equations involve addition and subtraction of several terms, a type of factorization is required. And I'm trying to emphasize, when do we need to do highest common factor factorization? When we have several terms with which we are adding and subtracting, and it's very obvious that our exponent variables are the same. Okay, that's the only way you'll be able to take out something that is common, really and truly, if the exponents are the same where there's a constant term. Let me just give you one more. Is it correct if I say 3 times 3 is equal to 9? 3 times 3 is equal to 9. Yes. 9 minus 1 is equal to 8. Yes. Over 3. Yes, that's fine, Barty. Okay. Me, I just decided to say use the calculator, but if you... Yeah. Because you're doing butterfly method. That's beautiful. No one is fighting. That is beautiful, Barty. Barty, nibona. 2 to the power x plus 2 minus 2 to the power x is equal to 12. Okay, here's another one for you. Let me just give you 3 more, guys. These ones you are going to do now. I'm just going to leave you guys to do them. And yeah, that will be the end of the live lesson for today. Okay, that will pretty much be it for now. Okay, then we'll look at the next aspect next time. Does that make sense, guys? Yeah, here are the 3 problems. Definitely you can screenshot. Go back to the last equation. This one. Ori 19. Ori, are you for real? Ori. Okay, hopefully you can see it now, my guy. Ori. Leadership. Leadership. You are thanks. Very good. I am very happy that you are thanks, my brother from another mother. So 2 to the power x plus 2 minus 2 to the power x is equal to 12. First question. Second question. 3 to the power x plus 1 minus 2 times 3 to the power x minus 1 is equal to 21. That's the second question. Third and final question. The square root of 9 to the power x plus 2. Everything is underneath the square root for the first term, minus 3 to the power x minus 1, there's no square root here, is equal to 26 over 7. Can we please not send the answers, Mr. Vikoma? You got 3. You're getting different answers. All right. It would be very shocking if my dear friend there, I just hope for the sake of, so those are the 3. Please guys, you can just do the problems, all right, and then we will look at the answers. What I'm going to do, I'm going to remove the comment section. Yes, we'll see the corrections. Please guys, let's do it, spend some time and do it. Let me remove the comments so that no one can comment and tell us their answers. This is just for you to check yourself if the concept has been mastified. Yes, so giving you some time to do this, and then I'll come back and we'll check it out. Just take some time, do it, As I said, the first one is 2 to the power x plus 2 minus 2 to the power x is equal to 12. The second one, 3 to the power x plus 1 minus 2 times 3 to the power x minus 1 is equal to 21. Then the last one, the square root of 9 to the power x plus 2, that's the first term, minus 3 to the power x minus 1, that's your second term, is equal to 26 over 27. Those are your 3 questions. So you have some time up until 5:20. Then we'll go over the corrections together. Actually, not 5:20, 5:16. That would be too much. 5:20? So you guys have like 7 additional minutes. 5:20, that's fine. Okay, so yeah, I'm sure guys, we must have made some headways there with the 3 questions. Yeah, correction time indeed. Oh wait, let's say x is equal to 2 for 1 and 2. Okay. Alright, so let's check it out. Check it out now. To God be the glory. Check it out now. To God be the glory. Alright. It has been, it will forever be that it's to God be the glory. Alright, let's check it out. Check it out now. To God be the glory. Let's check it out now. Two to the power x plus 2 minus 2 to the power x is equal to 12. So that is basically the question. Alright. So what we can see is there's a plus and a minus sign. We've learned just recently that whenever there's an addition or a subtraction sign for several or more terms, then we know that there's some sort of factorization that we are going to have to apply. So what we can see obviously here is that we can split 2 to the power x plus 2 to become 2 to the power x times 2 to the power 2, and that's all equal to 12. We then take out the common factor because there's evidently 1, because you can see 2 to the power x, 2 to the power x. Same brothers or same family members, the x and the x common, we take it out, we leave everything else. 2 squared minus 1. Very important, because whenever we take out the 2 to the power x, to the power x times what gives us back this? It's times the negative 1. Very important and crucial that we don't omit to do that. Then inside we have 4 minus 1, which is 3. So 2 to the power x times 3, guys, times 3. What do we do with this 3? We treat it as a coefficient. We treat this entire thing as a variable. We divide both sides by who? By the coefficient. We get 2 to the power x. We are back at grade 8. And it's nice when we're back in grade 8 because it's such a beautiful feeling. Drop the base, equate the exponents, x is equal to 2. So those who said x is equal to 2 for number 1, so beautifully proud of you guys. You did amazing. Phenomenal stuff, right? Phenomenal stuff. Yeah, Molimo, you see, that's the thing. And thank you for bringing that up, that you forgot the negative 1. What is the common thing that learners do whenever they are factorizing, and what they are taking out is the same as what is basically left for the is basically the same as the second term. You must remember, guys, that something times 1 gives you that thing back. So here it's 2 to the power x times the negative 1. I don't know how many times in my lifetime of marking learners I've seen this happen many times, where learners forget to put the negative 1 and they simply write 2 to the power 2 inside the bracket, and then it messes up everything. It really does. It messes up everything. Okay, so let's be careful about that. Okay, second question. 3 to the power x plus 1 minus 2 to 3 to the power x minus 1, which is equal to 21. So once again, what are we seeing? Base 3 cannot be simplified any further. It's already prime. He's already prime. You can see the variable x for 2 different terms, the same coefficient. So that means, once again, highest common factor. You see, guys, this thing. Yeah. So here we are going to split first. Play the splitting game. Right? Then after splitting, what do? We take out that common variable exponent. That's the most important thing. Just taking out the common variable exponent. Everything else leave inside. 3 minus 2 times 3 to the power negative 1 gets left behind for your second term on the other side, which is equal to 21. Be very careful. You took out 3 to the power x. So on the left, what are you left with? 3 to the power 1, which is 3. You take out 3 to the power x on this side. That means negative 2 is there, multiplied by 3 to the power negative 1 as well is left. So that's 3 to the power x, 3 minus, this is like saying 2 over 3. How do you get 2 over 3? Remember, this negative 2 times this 3 to the power negative 1. They are in the same numerator, but the 3 is raised to negative 1. So that means it changes position, moves from the numerator, goes to the denominator. Its exponent changes from negative to positive. So that's why we got 2 over 3. Because the relationship was one of multiplication, now we can write it as 2 over 3. Okay, does that make sense, guys? I hope that makes sense. 2 over 3. Let's continue. equal to 21. Then we are going to subtract 3 minus 2 over 3. Okay, it's going to give us 7 over 3. Very good, Anna, in the comment section there. 3 to the power x times 7 over 3 is equal to 21. Then we can divide both sides by 7 over 3, which is the same thing as multiplying by the reciprocal. We get 3 to the power x on the left, which is equal to, on the right, 21 times 7 over 3. What does that give us? 9. You can grab your calculator and say 21 times 3 over 7. Or you can, 7 goes into 21 3 times. 3 times 3 gives you 9. So you can, calculator guys, you can use the calculator. It will just make life easy for you if you really and honestly just don't want to be wasting your time. Same thing here, 3 minus 2 over 3, use your calculator, you get 7 over 3. Okay, usually the questions of this nature usually say solve for x without using a calculator. Let's remember, when they say without using a calculator, it doesn't mean you don't have to use a calculator at all. It just means you need to show your steps, okay, from beginning to the end, what you did, because the marks are attached to where your steps are. Okay, we are back at grade 8 now. I'm sure you guys know grade 8 stuff very nicely. 9 can be written as 3 to the power 2. You drop the base, you equate the exponents, the answer is x is equal to 2. Okay, then the last one, number 3. So you got 2 for both. It's almost as if like it was fate, it was destiny. Square root of 9 to the power x plus 2 minus 3 to the power x minus 1 is equal to 26 over 27. Okay, Pindi, I see you said you got negative 2. Let's see. Let us explore and see where it will lead us. So it's evident that we need to obviously apply the square root to this particular. Okay, and we can do that. All right. There's really 2 ways you can do it. It's really up to you how you want to do it. Okay, so I know some people who would say 3 to the power 2, okay, whilst keeping the square root. Then distribute the x, the 2. 2 times x is 2x, 2 times 2 is 4. You get 3 to the power 2x plus 4, whilst keeping the square root. Then remember, when you apply the square root to the exponents, it's the same thing, guys, as saying 2x plus 4 divided by 2. It's like you are dividing the 2x and the 4 by 2. Now I'm sure you guys know what that will lead you to. I'm sure you know what that will lead you to. 2 divided by 2, that gives you 3 to the power x. And then what's 4 divided by 2? That leads you to. So now that is basically what you wanted. Okay, to resolve the square root. Okay, well, some of you would have just not even done the division by 2. You know that when you are removing the square root, you can divide the 2x by 2, divide the 4 by 2, and then that should lead you basically to x plus 2 as your exponent. I'm sure from this point onwards, you know how to go. All right, so we are going to now split the bases, right? Then after splitting, After splitting the bases, you take out the common base with the variable exponent. That leaves you with 3 to the power 2 on the left, minus 3 to the power negative 1 on the right, which is 26 over 27. Then after that, what do we do, guys? This is 9 minus 1 over 3. Grab your calculator, you get 26 over 3, right? And you multiply by the reciprocal. What's the reciprocal of 26 over 3? It is 3 over 26. Okay, that leaves you with 1. 1 times 3 to the power x is 3 to the power x. Then on the other side, that 26 and the 26 cancel out. 1 times 3 is 3 over 27. 3 over 27 is 1 over 9. And then of course 1 over 9 can be written, remember guys, 1 over 9 can be written as 1 over 3 to the power 2, which is 3 to the power negative 2. So I can go directly to writing it as 3 to the power negative 2, which then gives me a value of x, as you guys have beautifully said, is negative 2. Okay. So yeah, sure. All right, guys, that is basically it for today. All right, as I said, these are not the only types of questions that you guys get when there is addition and subtraction involved of several terms. The problems I've done all the ones that involve highest common factor factorization, so that you guys can understand that concept, okay, that it needs the same variable exponents in order to be applied. This method, the highest common factor. But remember guys, there are other types of factorization, right? So we are going to look at the other ones when there is addition and subtraction in exponential equations. All right, how do we identify or see a question that needs us to not apply highest common factor but maybe difference of two squares, or one that cannot work with highest common factor? It cannot work with difference of two squares, but it works with what? With quadratic trinomial type questions. Okay, so yeah, thank you so much guys, and yeah, see you tomorrow next time. Yeah.